Hey guys, welcome back to our channel Get This Soon. In this video, we are going to discuss threats in operating system. This is the ninth video in the series of operating system. So if you haven't watched my previous videos set, then make sure you go and watch them. Also support our channel Get This Soon. Now let's get started. Before understanding the concept threat, we need to understand what is program and process. These we already explained and discussed in previous videos. Let me give you a small recap. Program is nothing but the code you write. Inside code, you write a set of instructions to perform a specific task. So, program is nothing but a set of instructions to perform a specific task. Now, what is a process? A process is nothing but a program in execution. When you execute the code, when you execute that set of instructions, the process of execution is known as process. Now, let's understand the new term here, that is thread. Before understanding term thread, consider this scenario. There is a recipe written as a set of instructions. Set of instructions means program. So consider this recipe, and executing these instructions is nothing but cooking. The cooking is a process. Set of instructions is the recipe, is nothing but a program. Cooking is a process. Now what are threads? Here, threads are the smallest unit of execution within a process. Now think of them as the kitchen helpers who take small tasks to complete the whole recipe. Here in this example, you can see the little helpers. So two people are helping in chopping, two people are helping in peeling, and one stirring on the stove. So each of these individuals represents a thread. These are tiny tasks but essential contributors to the overall recipe. So threads is nothing but the smallest unit of execution within a process. So what is a process? Process is nothing but a program in execution. Here you can see a process can consist of as many threads it needs. So here in one example we have 4 threads. In the second process we have 2 threads. Now let's see the definition of thread. A process can be divided into different small tasks that execute independently. These units are called threads. Here in the cooking example, you can see chopping is a small task, peeling is another task, stirring is another task. Together they are independently working, right? Here you can see a process is divided into different tasks that execute independently. Now also you can say a thread is a basic unit of execution within a process. This is one more definition. Now this is an important point. Threads allow for concurrent execution of tasks within a single process. Now what do I mean by the term concurrent execution? Here threads run simultaneously. Threads allow multiple tasks to perform at the same time. In the previous example, few people are chopping and few people are peeling. They don't have any connection. So concurrent execution at the same time, in the same simultaneously, they are working. So threads run simultaneously without any disturbance, and that is known as concurrent execution within a single process. I hope you understood. Moving ahead, we have two types of models, that is single threaded models, multi-threaded models. In single threaded program, there is only one thread. So only one instruction is running at a time. So chopping is done, then peeling is done, then something else is done. Only one thread is present, so one by one it happens. But what happens in multi-threaded models? Multiple threads run concurrently. Multiple threads do tasks independently at the same time, simultaneously. So because of this, the task completes even more faster and even more efficiently, right? Multiple threads run concurrently is known as multi-threaded models. There are so many methods how the multi-threaded models are mapped, like many to many, one to many, etc. that we are going to see in upcoming slides. Moving ahead, before understanding how these multi-threaded models are mapped, we need to understand there are two types of threads available. That is user threads and kernel threads. You already know there are two modes, that is user mode and kernel mode. Now, similar to that, we will understand user threads and kernel threads. User threads are managed by user level libraries. They are created, scheduled, synchronized, everything is in the user mode. That's why it is known as user threads. When compared to kernel threads, everything is managed by operating system. Created, scheduled, synchronized, everything is done by operating system. Here in user threads, when I said it is done at user level, OS have no idea there is something going on there. OS is unaware about these user threads. Moving ahead, we have lightweight and lower overhead. User level threads are lightweight because they are created at user level. It's very simple, and lower overhead also, it needs less resources also. But when coming to kernel threads, OS is involved in the process of creating, scheduling, and synchronizing. Therefore, the weight is also more. We need more overhead also. Moving ahead, we have blocking behavior. If a user thread in a process is blocked, it may block the entire process since kernel is unaware of the individual user threads. Just like I said, OS is not aware of user level threads. So if there is a problem in user threads, the entire process will be affected. Here in kernel threads, OS has full idea of what is happening in the kernel threads. That's why even if there is any problem, even if there is any block, entire system will not be affected with the blocking. Moving ahead, we have one more point, that is user threads are typically faster creation and faster context switching. Faster creation because the user level threads are very simple and very small, lightweight, and everything managed by user level for only small tasks, not the complex tasks just like kernel threads. In kernel threads, we have concurrency, parallelism on multiple processor cores. So user level threads is not as good as kernel level threads because OS is not involved in user level threads. When it comes to kernel level threads, all threads, everything is managed by OS. So concurrency and parallelism is maintained efficiently. I hope you understood the differences. If you have any doubt, make sure to comment below. Moving ahead, let's understand the mapping methods in multithreading. We know user mode, we know kernel mode, we know that is multi-threading means multiple threads are present. Now let's understand how these things are mapped. There are many ways, that is many to one to one, many to many to level. We'll look and understand. So we already know user mode and kernel mode. We already also discussed the multi-threading, which means multiple threads in the process run simultaneously, right? So how these multiple threads are mapped, how the user level threads and kernel level threads are mapped. There are four different models. One is many to many, one to one, many to one, two level. Now let's discuss one by one how this mapping is done. Let's get started. The first mapping method we are going to discuss is many to one. Many to one is maintained by user level threads. Many user level threads are mapped to one kernel level thread. That's why it is called many to one. Many user, one kernel. The operating system is unaware of the existence of user level threads. That's why if there is any problem also, if there is any blockage also, the entire process is blocked.